Hi everyone. So in this video we're going to be looking at finding the form of the particular solution y of p when g of t is what I'm calling compound. So here's an example of what I mean by compound. So in this differential equation g of t is more complicated than the examples that we were looking at before. The method that I'm talking about is the method of undetermined coefficients, and that's from section 3.8. But we saw what to do when when g of t is equal to t squared, or when it's equal to sine of t, or when it's equal to some exponential term. But this video is going to deal with what happens when you have all three together. So just as a reminder, I'm going to make a little table here. So assuming that we have no repeats from our complementary solution, so right, we don't have to add that extra t term like we do with repeated roots. If our g of t looks like t squared, then the form of our particular solution, we said we needed to be flexible with that. So we don't just write at squared, we say this is at squared plus bt plus c. And if g of t was equal to, let's say, cosine of t, then our particular solution wasn't just cosine of t, it was going to be a times cosine of t plus b times sine of t. And if it was, let's say, e to the t, then this one was relatively easy. We just said this is a e to the t. You saw in your homework what happens when you have repeats from the complementary solution. You just need to add an extra t term in here. So that's sort of the last step that we're going to be doing with this. But for this example that I've written here, go ahead and take a look at g of t and think about what might be the form of the particular solution if you just had to take a guess. So here's my g of t. And if you took a guess at this, you might just say, well, it's probably a combination of these three things, and you would be pretty close. But if I just sort of wrote out, at squared plus bt plus c times sine of t, right, well, I've got, d sine of t, and then e to the 10t, right? And then, oh, I actually forgot about the cosine term. So there's just a lot going on here. And we're also adding a lot of unnecessary constants here. So for example, multiplying this whole thing by d or multiplying everything else here by e, that's adding some unnecessary arbitrary constants in here. So this is not an efficient form. And it's also missing, right? We didn't even, we're all the way up to a, b, c, d, e without even writing the cosine term. So what I'm going to show you is a way to be efficient with your particular solution form. And if you do it this way, then you'll always end up with the correct amount of constants and nothing extra. First thing you want to do is, if you have them, you want to split into cosine and sine terms. So we'll split our particular solution into sine and cosine. Next step, we'll multiply both terms by a polynomial. They'll each get their own unique polynomial in there. And the third step is going to be to multiply everything. Multiply everything by an exponential term. That takes care of the kind of three compound situations that we have. The fourth step is going to be to check for repeats. And we're going to multiply everything by t for each repeat. Okay. If you follow this order, then you're not going to have any extra arbitrary constants. And you know, when we look back at this problem, if we happen to have any repeats from this complementary solution from YC, then if you're not following these four steps, then you might think, well, maybe I should multiply this part by t, or maybe the t goes over here. This just sort of takes all the guesswork out of that. So I'm going to pause this real quick and just change the color on something. There we go. I just wanted to separate everything. So let's look at the problem that we were given, or the differential equation that I wrote up top there. T squared sine of t e to the 10t. Okay, so step one is going to be to look at this g of t and split it into sine and cosine terms. So I'm going to say, here's my sine of t, and if this were sine of 3t or something else, then you would want that to be there to match that as well. But I'll say this is something times sine of t and something times cosine of t. I'm going to multiply both terms by the polynomial, and these are going to be unique polynomials. So I have a t squared here, so that means for this polynomial, or sorry, for the first polynomial, I'll multiply that by my sine term, and I'll start with d here. And multiply that same new polynomial times my cosine term. Step two. Step three is to multiply anything by the exponential term. So you can either put this out in front of everything. I just like to keep it out in front like that. And then 4 is going to be to check for repeats and multiplying everything by t for any repeats that happen. So for this one, I need to check my complementary solution. I'll skip the work for this one just to say that YC you end up with complex roots of plus or minus I here. So we get, this is going to be a cosine of t, or maybe I'll use C1 here just to avoid confusion. So C1 cosine of t plus C2 sine of t. Now, determining whether or not there's repeats can sometimes be a little tricky, but for this one I want you to think about this as being some constant, for example, some constant times sine of t, right? So we want to look in our particular solution to see if there's any constant times sine of t in that exact form. And when we look at this, we have some constant times sine of t. So we certainly have something that we might need to worry about. But this term is e to the 10t times some constant times sine of t. So the question is that a repeat? So I want you to take a second to think about whether or not that is repeating. And the answer here is no. If you think about the closest term that we have here, once we multiply everything out, the closest term that we have from this looks something like this. So multiplying everything, we have some constant c times e to the 10t times sine of t. And just like t e to the t and e to the t are independent of each other, this e to the 10t sine of t is independent from this one. So we can say even though it might look like it, we have no repeats from the complementary solution. Just by way of example here, if let's say our particular solution looked like C1 e to the 10t, so maybe alpha was equal to 10 this time. Right. Looks something like that, where it's e to the alpha t times sine and cosine of beta t. In this case, then we would have repeats. For every repeat that we have, the instructions that I wrote up top are that we should multiply everything by t for each repeat. I am counting this as just one repeat, or you can think about it this way. I could either multiply both of these terms by t, or I can just take everything and multiply it by t if we had a repeat. We don't have any repeats, so I'm not going to do that. What I attempted to do in this video was break down a table that you have in your book. Whoops. A table that you have in your book on page 163 in your book, and that will say something like this: if your g of t is equal to, so I'll give an example, e to the alpha t times sine of beta t, then it'll list the particular solution as this. So it'll say t to the r times A e to the alpha t sine of beta t plus b e to the alpha t times cosine of beta t. And I find this a little bit difficult to read, but what they're saying is you should split it up into sine and cosine terms like I did, and then multiply both of them by this exponential term. So you can either do what they did here or multiply everything on the outside. And then this t to the r term, r just represents the number of repeats that you have. So in our example, we had 0 repeats, so we multiplied it by just 1. But if you had 1 repeat, then we would just say t to the first power. Okay, so that's it for this video. The next one's going to be on higher order differential equations, and that is going to be the last section in this unit. So the next exam is going to be just on chapter 3 topics, and that'll be in about a week. So you can expect to have an exam. I'm thinking right now about April 8th, but I'll make a formal announcement of that. All right, see you in the next video.